Hello, this is Dr. Mears, and today we are going to be learning about using exponential models. So we can use many different types of models, such as quadratics, exponentials, and logarithms to make predictions. Exponential models can help us find initial values and other important information about a situation, and that's what we're going to look at today. Here's our example. The temperature, T, in degrees Celsius, of a cup of hot chocolate can be modeled by the equation T of x equals 70 times 1.45 to the negative x plus 21, where x is the time in minutes. So before I even start looking to see what I have to do, I'm going to label some of my equation to help me better understand what the questions are asking. So first, I see that temperature is in T. So this right here, which is our Y, is going to be temperature. I'm going to spell it out. Okay, so temperature is our Y value, which is our T of X. Okay, what's our X? X is the time in minutes. So right here, X is time. All right, let's keep going. Let's see what we need to do now. Part A, sketch the graph T of X for 0 is less than or equal to X, which is less than or equal to 12. What they have given here to us is a window. They want us to look at this graph between these two X values. So this is going to be a minimum X value that we're going to look at, and this is going to be a maximum X value that we're going to look at. And this is going to come in handy because I'm going to actually teach you something different with the graphing calculator. I've been teaching you to use the zoom method, and today I'm going to be teaching you to use your window. Okay, so let's get on with it. All right, first we have to take our graphing calculator, turn it on, and in graphing, what we have to do is press our Y equals. So we're going to press our Y equals. Anything that's in here, we're just going to clear out, and we are going to put this equation in, starting with the 70. Parentheses as well, and this is to the negative x, so I'm going to push my exponent button, and my exponent button is right above that division symbol, and it's a negative x, so please remember that your negative is down here by the 3. So negative, our x value is our xt theta n button, x, and then see how it has that little over arrow? If you have that little over arrow, you have to press the right over arrow button in order to get out of the exponent position because we still need to put in the plus 21. Okay, now we're not going to press zoom here. What we're going to press is we're going to press window. Window is right next to this Y equals button. So it says window right here. So I'm going to press it. And what's going to come up is X minimum, X maximum. We have that. They gave that to us. Our scale, that's what we count by. SCL is what we count by. Y minimum, Y maximum, our scale, our resolution, and then we have delta S, X, and trace steps. We're not going to worry about these last three. What we are going to worry about is just up to the Y scale. These we can talk about later. Let's just learn a few things at once. Okay, so we're going to put in for our minimum and our maximum of our X, what the points that they gave us. So we're going to put in 0, press enter, and then we're going to put in 12, press enter. And you'll notice the bottom numbers start to adjust. We always are, I'm going to right now say, always put your scale as 1. We can adjust that later, but for now, let's just put our scale as 1. So we're counting by ones, 1, 2, 3, so on and so forth. Now we get to our Y minimum. They haven't given us a Y minimum or a Y maximum here, so we need to do a couple things. So first, I'm going to just write down what we did for our X. So our X minimum is going to be 0. Our X max was going to be 12. We want to count by, our scale is going to be 1. And now we have to work on our Y minimum and our Y maximum and our Y scale. Okay, so first, our minimum. We have to understand what the problem is about, and that's why I had you label. We have temperature. So when we're talking about temperature of hot chocolate, I don't think our minimum is going to be very low. I don't think we're going to be going into the negative temperature unless we're outside and we're in it's a winter storm and our hot chocolate's negative 32. So since we're talking about hot chocolate, and they didn't tell us that we were in a big storm or it was very hot out. What we're going to do is I'm just going to start from 0. If you do want to start from -10, you can, or -5. Either one works, but you have to think in practical terms. This problem is about hot chocolate, so I am just going to start at 0. Again, you could do -10. That's fine. It is in degrees Celsius as well, so just to remember. Now our X max, and this is the maximum temperature that our hot chocolate is going to reach. And I'm going to show you a trick here. Our maximum, I would like you to first find the y-intercept, and then we're just going to go a little bit more. So finding our y-intercept for our max, y max, find y-intercept. So what we're going to do is we're going to pull out the numbers that we need. So we are going to pull out our K, our A, and our C, because we're going to eventually need those anyways down here. So our K is going to be 70, our A is going to be 1.45, and our C is going to be 21. And I do have a video introducing exponentials. It's exponential models part 1 and part 2. Part 2 explains how to pull K, A, and C out, so if you want to look at that, you can. To find the y-intercept, what we're going to be doing is we're going to be adding the K and the C together. That's always going to be where the y-intercept is. So here it's going to be 70 plus 21. So our y-intercept is going to be at 0.91. That's where it's going to intersect the y-axis. So for knowing that this is where it's going to intersect our x-axis, and I'm just going to draw this right here. This is going to be our x, which is going to be time in minutes. This is going to be our T of C, which is going to be our temperature. Already, I can tell you on our TFC or our y-axis, this is going to be 91. That's where it's going to start. That's how to find the y-intercept. So for our maximum, I just want to go up a little bit. So let's just round it up to 100. That's all. Just round it up because I just want to see a little bit above the graph because it's going to give us a nice curve. And our scale, I just want you to count by ones for now. Okay, so now that we found our y values here that we need, we're going to come back, go to our calculator, and for our y minimum, you could put -10. I'm just going to put 0. Our y max we found as 100, and I want you to do a y scale of 1. So now after all of this is over, what you're going to push is you're going to push the graph key. And the graph key can be found right here. It says graph. So let's press it. Pretty slow, but I'm used to my phone, which is a little bit faster than graphing calculators these days. Okay, so as you can see on the graphing calculator, we have a y-intercept of 91. This is going from 0 all the way to 12, and we're going to just draw that curve in. So we're just going to draw it in. Nice little curve. There we go. And that's it. Is it going to keep going on? Yes, it will keep going on here and here. That's absolutely fine. But our picture just doesn't show that because we put some restrictions on it. So it does travel up here and it will keep going on down here. But as you can see, this is going to be 91. And you can tell, look, all these little tiny tick marks here. That's going to be 91. This is going to be 12 here. And we sketched our graph. We have some numbers on here. We have a y-intercept, and we are good to go. Okay. What's next? What do you have to do next? Part B, find the initial temperature of the hot chocolate. Okay, this is a huge question because what you're going to find here is any IB question, they're going to ask you about an initial or a start point or where is our initial value or where is our start value. So when you see this, you need to think y-intercept. And you need to think x equals 0 because that is the y-intercept. X is 0. We want to know what that y value is. So when you see initial, you need to think y-intercept. Now we already found it here. So I'm going to show you 2 ways of doing that. First, you can find the y-intercept by using our k plus c. So we already know up here that our y-intercept is 0.91 because all we did was we added the 70 and the 21 to get 91. So this is the method that you can use with this equation. There is another method. So let's say our equation didn't look like this. Let's say it was quadratic or linear or cubic or some other equation. You may not even realize what type of model it is. So in any instance, you can use the second method, which is substituting 0 in for x. So when it says initial, you can always put 0 in for x. So t of 0 equals 70 times 1.45 raised to the negative 0, that could just be 0, plus 21. So even if you didn't know, if you forgot, oh, I don't remember how to pull out A, K, A, and C, that's okay. If you see initial, substitute 0 in every single time for x. Then we could just use our calculator, whoops, throwing it there, second quit, and we can put in this side, 70 parentheses 1.45 to the, if you want to put negative 0 in, that's fine, plus 21. Just remember to get out of that exponent position, enter, and we're going to get 91. And so we were able to find it either using the actual formula and adding k and c together to get 0, 91, or substituting 0 in, and we see we get 0, 91. So either way, I also need you to write it as a point. I need this 0 here so that you understand that this is the y-intercept. Then we can make a complete sentence. Initial temperature was 91 degrees Celsius. And this matters because it tells me that you're understanding what the problem is about and that we're using degrees Celsius. So this is important to write your complete sentence, and it's important to write it as a point so that I know, you know, hey, I'm looking for the y-intercept. This is what it represents. Part of communication. Okay, what do we have to do next? Find the temperature after 5 minutes. Okay, so this one, they're giving you minutes. What's minutes? Minutes is x. X is time. X is time in minutes. So they're giving us the x. So you're absolutely right in your thinking. Right now they're giving us an x value. X is 5. So what they're going to want us to do is they're going to want us to take the original equation and, yes, substitute our x in. So t of 5 equals 70. 1.45 to the negative 5 plus 21. You're going to put this in your calculator just like we did here, but now it's negative 5. And you're going to come out with, when I put my 5 in, 31.9. And then you're going to write the sentence, temperature after 5 minutes was 31.9 degrees Celsius. Again, this is telling me you understand what you're finding, and this is showing me how you actually received the answer. Okay, perfect. All right, let's go on. What's next? Part D. Find the number of minutes it takes for the hot chocolate to reach 50 degrees Celsius. Okay, so what information? We need to find the number of minutes. So here, we don't know what our x is. No idea. So that must mean that they gave us the t of c, which is our y value. Okay, this is, remember, the temperature, that's the t. So let's write down our original equation. Nope, not negative 5. I was stuck on the other problem. Plus 21. Okay. And are we going to replace x? No, because they're asking us what is our x? What are our number of minutes? We're going to replace the 50 and with the t of c with the 50. So 50 equals 70 times 1.45 negative x plus 21. Now, here's the thing. Have I ever taught you yet how to solve this equation? And no, I have not. So we cannot use algebra to solve this equation right now. Will I in the future and have a video on that? Most definitely. But right now, in our course in 2023, I have not showed you yet. So what we have to do is use the calculator, because I have shown you how to solve equations using the calculator. And I'm going to refresh your memory right now. So the first thing we have to do is we have to separate these. Okay, one's going to be y1 and one's going to be y2. So this side I'm going to take as y1. This side I'm going to take as y2. The equal sign separated them. So in my calculator, I'm going to press the y equal sign. And then in y1, I'm going to enter 70 times 1.45 to the negative x plus 21. And in y2, I'm going to enter 50. And what this is going to give us is the curve and a line. And let's see what that looks like right now. So grab your calculator, turn it on, press y equals. We already have the first one in, so we have to go down to the second one, y2, and we have to put in 50. And here's the thing. This equal sign says I want to know where they're equal, which means I want to know where they cross. So let's press graph. And as you can see, right here, this point where they cross, where they intersect, is our answer. So our x value, because remember, we're looking for x, of where they cross is going to be your answer, because this point, their intersection, is where they are equal. So let's find that. Now, you have done this before. Okay, so we pressed y equals, we put this in, then we pressed graph. Now let's go find their intersection point. So when you find their intersection point, we're going to have to press second trace. So remember these steps, second trace. So let's do that. Second trace. Okay. We have to find, you're right, number 5, intersect, where they intersect. So that's what we're going to push. Number 5, intersect. So let's push it. Number 5. Okay. Please notice on the bottom it says first curve. The first curve is this the first equation that you want? And so it's on the blue one. And so I'm going to say, yes, this is the first one that I want. The reason why it does that is because we could have 5 or 6 on here, or 10. So it just wants to know, is this the first one? And so what you're going to do when it says first curve is you're just going to press enter. Okay. Now let's look at the bottom. It says second curve. So it's asking you, is this, I know it's not a curve, it's a line. But again, we could have curves and lines. They just named it curve. So is this the second one that you want us to find the intersect for? And you are going to say yes. So you're going to press enter again. It did not give you the answer yet. What it asked you is, do you want me to make a guess based on these two curves, or this curve and this line? And you're going to press enter. And you're going to wait a second, and you're going to see, here's our intersection point. And this is where these two are equal. And so you have to realize, what are we looking for? Well, our y is 50. That was what we wanted. We wanted the temperature to be 50. And we need to find out how many minutes. And we see it's about 2.371591. Let's round to, let's do 2.37. Let's go 3 significant figures. So I'm going to write down on your calculator, you had x equals 2.37. You had y equals 50. And so this is going to be your T of C, which was your temp, your temperature. This is going to be your X, which was our minutes. And so what did the problem ask for? It asked for minutes. So what we're going to do is we're going to take this number and write it in a complete sentence. How many minutes it took? 2.37 minutes for the hot chocolate to reach 50 degrees Celsius. There we go. And that's 7. Does it look like a 7? There we go. Okay, so you have to remember how to use your graphing calculator, the intersect feature, and then which one you're looking for. Setting up notes like this definitely does help. All right, 2 more to go. Let's see what they want us to do now. Part E, write down the equation of the horizontal asymptote. Okay, so let's just look back at this graph really quickly. Now, the horizontal asymptote is the imaginary line that this blue curve, it's an imaginary line that it will never cross. So we have one here, so it's coming down, but there's an imaginary line that blue curve will never cross. We need to find it. And so that's called our horizontal asymptote because it's going horizontally. There is a vertical asymptote that goes vertically, up and down. So there is an imaginary line that this graph will never cross, and it's a vertical horizontal line. But which one do we want? We want the horizontal one. So we want this way. So this way, there's a horizontal one. It's going to cross. It's an imaginary line. It crosses the y-axis. We need to find what that is. Now, in my other video, you knew when you pulled out your K, which was 70 for us, our A, which was 1.45, and our C, which was 21, the horizontal asymptote, this imaginary line that it will never cross, will be at that C value. So instead of writing Y, I'm going to write T of C because this is our Y. So instead of writing Y, I can write T of C equals 21. And I want to prove that to you with the graphing calculator. So what I'm going to do is I'm going to press Y equals, and instead of writing 50, I'm going to write 21. Okay? And I'm going to show you that this curve will not pass this line by pressing graph. It is very particular about making this curve. Oh, comes so close. It really does. It actually looks like it would touch there, but I bet you if we zoomed in to that point, I bet you it wouldn't even be touching, and I'm going to actually zoom in because it looks like they are touching there. So let's zoom to, and let's see, does it touch right there? I bet you it doesn't, and I bet you this is going to, it's so funny how long it takes for this calculator. I usually use the yellow school ones, but I was like, oh, let me use mine. Okay, let's see. Oh, it gets so close. Look at that. It doesn't even touch. And I bet you if we kept zooming in and moving over and zooming in, this blue line will never touch this blue curve will never touch this red line. And that's the sad story about math because they'll never meet. They want to, but they will never meet. Okay, and that's a big concept. Let's move on to the last one. We need to write down the temperature of the room. Ooh, the temperature of the room. So the temperature of the room is going to be at C. So C is going to be the temperature of the room. So RC was 21 degrees. So 21 degrees Celsius is the temperature. And that's it. All right, so this has been our example using hot chocolate, our exponential model, and we did a few things. So this is a really good example that we hit initial temperature, we substituted an X value in, we substituted a Y value in and used our graphing calculator feature. We found the horizontal asymptote and proved it would never pass there, and we found the temperature of the room. I hope it helped.